I just want to show you a couple of things that are a little bit more advanced than what we'll be learning today. But I made this in Plotly. So Plotly allows you to have interactive graphs. So if you scroll over the bars, you can get the percentage. So that's through Plotly, and Plotly can be on top of any graph that you can make in R. So if you make a ggplot graph, you can put Plotly over top of it and make it into an interactive graph. And this is something that we're going to actually learn how to make today. So it's a correlogram, which shows the correlations between my variables, and then the x's represent ones that are not significant. So we are actually going to, at the end of the day today, get up to this point. Okay.
For our dating charts as well?
For what?
X's are ones that are no longer.
Yeah, process of elimination. Okay. Okay, so does everyone have the data downloaded? Okay, so we're going to be working in RStudio today. So you need to have both R and RStudio installed, but RStudio is the user interface that we're going to be using. So everybody go ahead and open that. And then we're going to open an R script. So an R script is what this piece up top here is, and that's where we're going to keep a log of our data, but we have to actually run it and send it down to the console in order for it to actually do anything. So first go up to File, New File, and then R script. Okay, so first what we're going to do is type d equals read.csv and then file.choose. So what this does is it's saying read a CSV file, which is the format that our data is in, and then file.choose will pop open a browser window so that we can select the file. So now you see I typed this in, but it's not doing anything because it's just up in the script. So in order to actually run it, we need to send it down to the console by hitting Command Enter or Control Enter for a PC. So Mac is Command Enter. So you see now it sent it down here, and now I can select the file. And now if we look over here in my environment, I have a data frame that is called D. Okay, any questions on that piece? So we want to make sure that everyone has the data brought into R. So we can go ahead and take a look at what the column names are. So if we run column names D, you can see that they're super long names and not really helpful for typing them out a bunch of times. So first thing we're going to do is change the column names. So if we do column names of D, and then I'm going to say equals, and then C. So this C function, it stands for combine, and it's telling R, I'm going to tell you multiple things now, and I want you to combine it into one thing. So we're going to rename our column names, and I'm going to name them time, email. So right now I'm just shortening them so that it's easier for us to work with, so we have better column names. From last, which for the, did you attend the last one? Experience. Software. So you can see that I am hitting enter after a certain portion of the code. You don't have to do that. You can have spaces, no spaces, you could have it all on the same line. I'm just doing that so it doesn't run off where you can't see it anymore. But you don't have to have spaces. Can anyone who was here at my first workshop tell me why I'm using quotes? Yes, Heather?
Because you're telling it that you want to use those as names, not that there is an object
Yes, perfect. So her answer was, the reason why I'm using quotes is because I'm telling R that I want this character called years. There's no object that I want you to call in that has things saved under the name years. So we're telling it that this is a character string. No, she was not a plant in the audience. I was very excited that she got that right. Okay, so go ahead and let you guys have a minute with that. So if I run that code, now that this is the new names of my columns. So make sure that you guys run this after you have typed that all out. Make sure you run it or else nothing will happen and you'll have yes. Yep, you're right. Thank you. Which goes here, right? After yes. Thank you. Yes.
I'm actually having a problem with opening this.
Okay, let me come out. That's something else that I want to mention. If you guys get an error or you get stuck at any point, please let me know so I can come over and help you. I've built in plenty of time for as many mistakes as we need.
Sorry.
Okay, no.
I sent my downloads right now, but this doesn't seem to be doing like anything.
Okay, so it's probably popping up behind your R
Okay.
session. Yeah, I don't know why it does that.
I don't know if it did.
Okay,
or not,
close this.
but You're right. I think this is
This, yeah.
Oh.
So it
okay.
just the same thing happens on the lab computer. It pops up behind it. I was like, what? Like it should be in front. Okay. Yeah. So if anybody else is having the same issue with file.choose, like half of the computers, like the pop-up window pops up behind RStudio. I don't know why it does that or under what conditions, but it probably is coming up under. Yeah. So can you?
So I do it and it gives me this message.
Okay, let's see. Hold on, let's close this and try running this again. And then click on.
It just saved it.
Okay, so right now this is an Excel file. You need to have the CSV file.
Okay.
Yeah, I don't know what I did. Like, it just keeps saying there, and I thought I put everything in right, but I don't think I did.
You might be missing a comma. Yep, there you go. Perfect. Good job. You're missing a comma right here between position and attempt. Okay.
My stuff was kind of loading when you were talking about what to do after you took this first. I did everything else, but did you say to like click?
Yeah, so if you run this, it'll pop up. Then you can run. Yes, yep.
Quick question, sorry. I don't know why I'm hitting enter, but it's going to this, like it's not indented. Like it's like a one line.
I'm not sure. It seems like it's just a formatting issue where it's like not, but it's still running correctly, right? Okay, yeah, then you should be fine.
Okay, because I got to my file.
You're missing something here. You're missing quotes. There you go.
Okay, thank you.
You're welcome. Okay, does everyone have the data loaded into R and have their column names changed? Okay, so if you've gotten to this point, that's great because you'll be able to follow along for the rest of the time. So this is an important piece. So if you're not at this point, let me know so that I can get you. Okay. But you don't have an error or anything? You're just, okay, you just need a second. Okay, so if we wanted to look at a histogram of people's R experience, we can just type hist and then $experience. Why am I getting this error? Because I never reran this. Okay, so if you guys remember from the last workshop, $D something, so D is the name of our data set, and then the $sign is telling us that I want a column within this data set, and then whatever follows that is the name of the column. So here we have a column named experience inside of the data set D, so D $experience is going to give us that specific column. So here I'm using hist, which is a function in R that is going to ask for a histogram. So if we take a look at, let me close these. If we take a look at this, which is super small, which I did prepare for. So let me run this. Is anyone still struggling to get to this point? For those of you who came in where we renamed the columns. Okay, I figured you could handle that part. Okay, so because I have it plugged into the projector, it's going to make stuff super small, so I just have this R Markdown file that I'll switch back and forth between. But so this is what your output should look like. So a histogram of D $experience. So that's exactly what I asked for. So you can see that we have a skew going on there. Is everybody caught up? Okay. So next, let's ask for a scatter plot of the number of years by experience. And we get a scatter plot that is the basic scatter plot that comes with R. But this is pretty basic, and there's not a lot that we can do to change it. So we're going to use a package called ggplot2, which is more flexible and will allow us to make more changes than just working in base R. So if you don't already have it installed, run install.packages and then ggplot2. I'm not going to run that because I already have it installed. So I'm just going to run library ggplot2. So the reason why we need both the package installed and to run this library command is because if we automatically had all of the packages ready for our disposal, that would be a lot of memory that we would be taking up. So R handles this by having these libraries where when you call it, then the stuff that's inside of that is ready for you to use. But if not, then it's not wasting all your space on your computer. So we have to say library ggplot. Okay, everybody have that installed? Anybody still waiting on that? Okay, so we're going to use the ggplot function. So let's say that we wanted a bar graph of experience by gender. So we would use this ggplot function, and then the first argument is what is the name of our data set. So in this case, our data set is called D. So ggplot and then D. And then AES is the next argument that it's looking for. AES stands for aesthetics. So what this is doing is we're telling R what variables are we going to use in this graph. And this part is just setting up what our graph is going to look like. So in this case, we want gender to be on the x-axis, and we want experience on the y-axis. So if we were to just run this, it would give us a blank graph with no data on it, but the axes set up the way that we want it to. So since we are saying that we want a bar graph, to this we're going to add something. So the way that ggplot works is it has these base components that then you can add something onto. So you can have a graph a certain way and then do a plus sign and then add another argument to it, which will then change that graph. And you can continue to add onto it, and it'll continue to change in a certain way, whatever you're adding onto it. So in this case, since we want a bar graph, I want a bar graph of the means. I don't have any data in my graph that specifically says mean, so I need to calculate that first. So we can use the stat_summary function, which will allow us to use a function and apply that to the data. So I'm going to make this a new line just so that you guys can see it, but you don't have to. It can all be on one line is fine. So we're going to say fun.y is equal to mean. So what this is doing is this is saying that I want a function applied to my y variable, which in this case is experience, and I want that function to be the mean. So there's a function in R called mean that takes the average. So I want to apply this function to my y variable. And I also need to tell it what shape or what type of graph I want. So that's where this next argument, geom, comes into play. So geom is how ggplot distinguishes what type of graph you want. So in this case, we want a bar graph. So geom is equal to bar. So if we run this and take a look at what it looks like, we have this graph. Let me see if I can make it smaller. Okay, so we have this bar graph of experience by gender. But let's say I wanted my bars to be horizontal instead of vertical. I can flip those by keeping the same piece that we already had, so this ggplot and then the bar. So everything that we just had, and now add onto that chord flip, which says to R, flip the coordinates. So this chord flip piece is telling R, flip the x and y, flip it, so that it's now going the other way. So now if we take a look at what this looks like, it's still I want it smaller so that we can see. Okay, so this now has the bar graph just turned on its side. So now it's horizontal with this chord flip function. Yes? Okay, yeah, let's take a look. Yeah, no, so that's fine. So this is a great point that I want to make to everybody. When you install a package, it might seem like it has errors just because it's giving you some information in red. That's not necessarily a bad thing. It's just telling you this information. I'm downloading from this source. I'm getting this other package that I need to be able to use this package. So it's just going to give you a bunch of information. If the library command works, then you're fine. But it'll just, when it's installing, it gives you a bunch of information of, I had to get this other package, I had to do this thing. It's just telling you what's going on. Okay, try try going to packages over here. And then hit install. And then GG. And then ggplot2. And then hit install. Is anyone else having trouble installing ggplot? Lots of you, okay.
So my ggplot seems to be installed and working,
Mhm.
but it keeps having a little pop-up that says there's an error in the retrieval, and I get this over and over again. If I hit OK, it just comes.
Okay, just hit escape twice, and now do it again. Do the library ggplot2, see what happens. Okay, so you probably don't have your data set read incorrectly. So if it's graphing something that's not in your...
But I did read the column.
Okay, I see. So
I read these and then I matched it.
yeah, so this
To be fine.
you're missing something here because you're graphing where it says gender, you're
Yeah.
graphing favorite color. So you're missing... Sorry. Yeah, so double check with, do you have the, you had it read incorrectly? Double check that you have the same order of the columns because I think you might have the columns flipped. Yeah. Thank you, thank you.
ggplot just isn't found at all. It says it's downloaded, but there
It didn't download a dependency, and then we tried to install the dependency rlang, and it's like not letting it.
Oh.
It's one of those weird like buggy things.
What's
again.
your type version into the console, just version and then enter and see what version of R you're running. Yeah. Yeah, you're running the 2016 version, which might not be compatible with some of that. So you might want to just update your,
R or R Studio? Probably both.
yeah, probably both.
Weird. I did that before too.
Okay, then yeah, try your R. Yeah, so it's saying that you don't have a function ggplot, which means that you didn't open the library correctly. So let's try to run this. Yeah, so this didn't install correctly.
Okay, how does that install correctly?
Hold on, let's see.
Did you just hit Command Enter?
Yeah.
Do you always have to open the?
Okay, so it worked now. So yep, so you're good to go now. You're all set.
Okay,
Mhm.
all right, thank you.
Okay, yeah, you just need to
So I imported the data and ready to rename.
You need to rename the columns. Well, first of all, you didn't import it correctly because you have the column names as the first row. So if you run type, here, let me just help you out.
Just do it.
Do you know where you saved it?
Desktop.
Okay, here, I'll let you click it. Okay, and then we just need to rename the columns. This might be out of order now, I'm not actually sure. Okay, so whenever I type, okay, hold on, yeah, I'm almost. Okay, so now you should be all caught up. That's okay.
It's saying, I don't know if it's maybe trying. It was trying to turn off the version of it that's
Yes. So type version down in the console. Yeah. Enter. Yep. Oh no, you have a pretty up to date.
I
not
just
that
did this
old.
in August. Like that's when I
Yeah.
downloaded it.
That should be fine. Oh, because you already have ggplot too.
I
so
deleted
that's why.
it though and tried redoing it. I did.
Okay, try just running the library.
Yeah, that's okay. So it's like just this part.
Yeah.
Is corrupt.
Let me.
Has this happened to anyone else?
No, let me uninstall this. Okay, so I'm gonna run uninstall. Is it uninstall the packages? What is it? I have no idea. Let me have shots come over. Can you help somebody? It says that their thing is corrupt, and I don't know what to do.
Am I the expert on corrupt?
Yes. Can you help? Can you help, Kim? Okay. Is anyone else having difficulty installing ggplot2? Is it the same? Okay, I'll have him come over because I don't know why it's not been. Try here. Let's try running version.
A very good art teacher.
Thanks.
Valeria and I are based on her expert knowledge.
Oh yeah. Okay, so this is the problem for you is that you're running the 2016 version of R, so you need to update that before you can. That's okay. Yeah. So that's why it's not.
I have no idea.
Also, my laptop may or may not die, so I might have to like awkwardly
Relocate.
stand in the corner.
Okay. Okay, so I'm going to run through a couple more things for the couple of you who are still trying to get ggplot installed. You can just sit tight and watch for a little bit, and then hopefully Shots will come over and get you all fixed up. Okay. So let's say instead of a bar graph, we wanted a box plot. So we can keep this first piece because we still want to use the same variables, but we want, instead of a bar graph, we want a box plot. So I can add to this geom_boxplot, and when I run that, I will get a box plot, but okay, so this is what it should look like. So I added geom box plot to this first piece that we already had. So it's using the same variables, but instead of a bar graph, we now have a box plot. So that's an example of how what this addition piece, what follows that is going to change it. We're using the same variables, but now we're getting a box plot instead of a bar graph. Okay. So instead of looking at experience and gender, let me stop there. Does anyone have trouble getting a box plot? Okay. So instead of looking at experience and gender, let's take a look at experience by software, and let's make a line graph that also is broken up by gender. So we're going to say ggplot, and D, because our software or our data is still D, and AES, because we want to tell it what variables we want. And instead of gender, we're now going to use software. And then we're going to use experience again as our Y variable. And we're going to say group equals gender and color equals gender. So the reason why we need to have both of these pieces, both group and color, is because if I were to say just group equals gender, I'm going to get two lines on my graph, but they're both going to be black, and it won't tell us which is which. So we have to include both group and color. It seems a little bit redundant, but if you didn't have both pieces, you would just get two black lines that wouldn't help you distinguish. Yes, so you don't have to put x equals or y equals. That's actually a great question, thank you. So you don't have to put x equals y equals if you're putting it in the order that the default settings are. So since the AES function takes x and then y, I can just leave that off and it'll automatically assumes. Same thing here where I'm just putting in D. I could have typed in data equals D, but since I know that in the ggplot function, the first argument is data, I can just go ahead and put that right in there. But if I wasn't sure about what the order is, or if I wanted to put it in a different order or exclude something, then I need to tell it exactly what I want. Any other questions on that? Okay, so we've gotten this far with our the main piece of our statement, but we need to tell it to make a line graph. So right now, if we were to run this, it would just give us a blank graph. We haven't told it that we want it to be a line graph yet. So we're going to use the stat summary function again, because I want to graph the mean. So we're going to do fun.y equals mean, just like we did before. And instead of geom bar, we're going to say geom equals line this time. So we are keeping this first piece the same. Fun.y is telling it that we want the mean to be associated with our y variable, and then geom line is going to give us a line graph. So if we take a look at that, it should look something like this, where we have this line graph. But as you can see, this is not the best graph for this particular data. So because we can't necessarily see where the particular, you can kind of see, okay, it turns here, but we're not sure, is there a spot here, or is it just going through there? So let's try to use this same base piece, but we're going to change so I want everybody to just copy what we have, but instead of having this geom line, we're going to change it to bar, and then we're going to add on to that position equals position dodge. So what this does, so what position dodge does is it says, I want the position of my bars to be next to each other, right up against each other, not overlapping. So you can put, if I were to put inside here, I were to put like 0.9, then it would be like close to each other, but there'd be a little bit of a space in between. So position dodge right now is just saying I want them to be side by side but not overlapping. So if I run this and I take a look at what it looks like, you can see that now we have these two separate bars for male and female, and they're up against each other. And you can see also that there are no males who reported using Excel, so we don't have a mean for experience there because you can't have a mean of nothing. So it just fills, it lets females have the, yeah, you have a question?
I need to change the fill argument.
Oh, yes, thank you. So if you just run the, this color equals gender, it'll give you just an outline, but we can do fill equals gender as well. And now what that's going to do is the inside of the bar graph is going to be filled with a particular color. So if we leave that piece off, as you guys probably saw, we just get the outline of the bars to be a particular color, but the inside is still gray. But if we do that fill equals gender, then that makes the fill or the inside of the bar to be that particular color. Thank you. Does anyone have questions on that? Yes. Okay, let's take a look. You are missing a parenthesis at the end. So position dodge is a function, and then you need to close the whole ggplot, the stat summary piece. Getting there. Let's see. Okay, so right up here too, you're also missing a parenthesis because you have to close the AES function and the ggplot function. So now if you run that, and then here you just misspelled position. Probably because I misspelled position. Did I misspell position? Oh no, that should be right. Oh, it's position underscore dodge, not position dot dodge. Yep. Okay, any other questions on this? Anyone else having trouble? How are you guys doing? Okay, good. Anybody else? Yeah. Okay, so D is the name of the data set, so that means that this first part is wrong. So rerun this first line.
Yeah, what do you do when you
You select the file that I sent out. So the file that you downloaded, did you get the email with the?
so you save
Yes.
this to somewhere and then choose that?
Right, yep. So you're selecting that file.
This is whatever and then save this.
Yeah. Sorry. Okay, any questions up until this point? Okay, so let's make a different type of graph. So let's make a scatter plot. Yeah, you have a question? That does not matter. Nope, it doesn't change anything as long as you have, as long as you're within a statement. So if you see it here, I have at the end of the plus, then it's going to the next line, and here, like, I have it because it's like within this parenthesis. It knows like I'm still waiting for more information because we haven't closed the parenthesis. So that's why a lot of times when you leave off a parenthesis at the end of your statement, it'll still have the plus sign because it's like, oh, I'm still listening for more information within this function. But so if you run into that issue where you're seeing a plus sign like this instead of the caret, hit double escape, and that'll get you out of that loop for whatever reason you got stuck in it. Good question. Anything else? Okay, let's make a scatter plot. So we're going to do ggplot and dataset D, AES. And now let's do X is favorite number, so favnum. Y is equal to years, so that'll be on our y-axis. And then color is equal to favorite color. Okay, so to this, we're going to add geom point. So geom point is it's years. Sorry, guys, it's years, not year. So we're going to get this error message here, and what that's telling us is that we have 2 missing values. So you can see remove 2 rows that have missing values. So if it doesn't have a value for one of the things that we called, it's not going to graph it at all. So if it's missing, it's just going to say we're going to completely remove these 2 data points so that it won't show up on our graph. So that's why you see that warning message. So if we take a look at what this looks like, you can see here that the colors are still the default. So you can see here we have black corresponding to red and blue corresponding to orange. So that's not super useful in if we're trying to graph favorite color. We want color to correspond to the actual color that it's supposed to be graphing. So we can actually change those default colors to be any color that we want it to be. So what we need to do is create a key for R to know what value we want to be what. So I'm going to say cols is equal to, and then again we're going to use the C function telling R, I'm going to tell you multiple things. So we're going to use C, and then I'm going to say red is equal to red. So what this part is saying is the first piece is what is it in my data, and then the second piece is what color do I want it to be. So R has colors that are already associated with words, so I can just say red. I could also say like red 1 or whatever here, or you can say like dark green. So they have certain colors that are associated with those things. In this case, we can just go ahead and type out red equals red, orange equals orange, and just go through it that way. Okay, so after you've gone through the rainbow, then we have a few that aren't in the rainbow that we included in our survey. So pink, brown, and black. You need to add those in as well. Okay, so when we run this, what this is right now is it's just a vector with random things. We have not associated it with our graph yet. So this is just a list that's telling that red is equal to red, orange is equal to orange. So once we have that all typed out, we can actually tell our graph that we want it to make the graph consistent with these colors that we have identified. So we can keep this piece that we had before, this ggplot geom point, where we have this made the graph, but it was in the wrong colors. So it's still what we want. We just want to add something onto it. So we're going to do the plus sign. and we're going to say scale underscore color underscore manual. So what this is saying that I'm going to manually tell you what I want these colors to be. So that's what scale color manual is. I'm manually telling you what I want each of the values to be. So we're going to say values equals cols because we have this this vector that we identified as matching all of the colors that we want. So if we go ahead and run this, again, we're going to get that error message because we have 2 missing values. And now you can see that our colors are associated with the correct colors from our responses. So you can see that we have a black dot corresponding to black. Okay, any questions on that? Yes. That's a great question, actually. You can Google like our colors, and it has like a huge sheet of like all of the different colors in their color and like what they're named. So off the top of my head, like I don't know all of the colors, so I can like look it up and know that okay, like cyan 1 is like this version of it, or like I can do like cyan 3 is like a different tinge of that. So it's super easy to find. Like you can literally just Google like our colors and it should come right up. But most of the colors are like, if you type in the name of a color, like it should come up for you. Like they have a pretty comprehensive, like I can type magenta and like a magenta will come up. So it's pretty good in that way. Okay. Any other questions? No? Okay, so let's say that I also wanted to take a look at gender here. So we're going to keep this piece that we just used, but we're going to add on to it again. So here we're going to keep the same thing, and we want to make facets. So what facets do is it separates it into almost like 2 separate graphs, but on the same graph. So if we say facet underscore grid, and then so we have to tell it how do we want our facets to be laid out. So if I wanted to have vertical facets, I'm going to say dot predicted by gender. So what this dot is this is saying everything. I want everything that I've already said predicted by gender. So if we run that, we're going to get these vertical facets where we have 2 side-by-side facets of females and males in 2 separate facets. So this facet underscore grid and then dot predicted by gender. Okay, but let's say we wanted them to be the other way and we actually wanted horizontal facets. We can just flip. Instead of dot predicted by gender, I can do gender predicted by dot and run that. And then we get horizontal facets. So now the faceting is going in the other direction. So all I did there is I changed, instead of dot predicted by gender here, it's gender predicted by dot. So that's going to flip the direction of the faceting. So we went from horizontal to vertical, or vertical to horizontal, I mean. Okay, any questions on that? Okay, so I could also here, instead of having the dot meaning everything predicted by gender, I could have 2 types of facets, which will give me like a facet grid of, like, let's say I had another dichotomous variable, it would give me 4 facets. So I would have a facet here, a facet here, a facet here, and a facet here. So female, and then let's say by, what's another dichotomous variable? I'm like blanking right now. Okay, so let's just say 0 and 1. So we would have female 0 here, female 1 here, male 0, male 1. So that would be instead of having the dot if we put in another dichotomous variable. It doesn't have to be dichotomous. It could be, you could have like 4 facets. The more you go, it gets a little, yes, it has to be categories. but it doesn't have to be categories of 2. It can be like a lot, but I recommend not going crazy with the faceting. I've seen some like crazy facet grids, and I think that it can just get a little bit overwhelming. So I suggest trying to keep faceting to maybe like 4 or less variables so that it doesn't get too overwhelming.
Like what if I wanted to put it in school and I had 60 schools?
Yeah, I don't recommend that. That's one of those crazy facet scenarios where I think that it's difficult for people to really compare that many things at the same time. So if you're looking at 60 different graphs, if it's super obvious, sometimes it's like okay to look at, but I think that if they're all like only slightly different, it can get like a little bit overwhelming. So, but yeah, you could have a facet of 60 different schools if you wanted. You could. I don't recommend it. So in that case, what you would want to use instead of facet grid, I would use facet wrap. So what facet wrap does, so instead of facet grid, we would change this to wrap. It'll wrap it like literally so that you'll have like a few and then down to the next a few. So it'll wrap so that it like you go on like how you read, where it, like left to right and then you continue on under. It'll do that. So facet wrap if you have more than if you had 60 schools that you wanted to do, I would use facet wrap for that. Okay, any other questions on that so far? Okay, so let's say I also wanted to include your experience in this graph. So we can throw an extra argument in here. So we're going to keep everything that we just did. And up here in the AES piece, I'm going to say size is equal to experience. Let me make this. So if we run this, you can see that we have different levels of experience corresponding to the size of our dots on our graph. But as you can see, there is a lot of overlap here. So if you wanted to make sure that you were accounting for all of the dots on the graph, we can change the alpha level. So what alpha does is it changes the transparency of the dots. So again, we're going to keep everything that we had. And if we were to put alpha up here in the AES argument, so I'm going to say alpha equals 0.5. And make this a little bit bigger so that you can see that there's a plus there. So if I were to run this, what this is going to do is it's going to give me alpha for everything. So anything that's inside of this AES argument carries over to every single thing that's in your graph. So if I were to add both points and lines onto my graph, if I have AES on the inside of, if I have alpha on the inside of my AES argument, it's going to make both of my points and my lines transparent. So if I don't want that to be the case, so you can see here I have this alpha is 0.5 over here for my entire graph. So I don't want this. I don't want this to say 0.5 here. I can take it out from that AES statement. So see here where I have alpha equals 0.5. I'm going to take it out of there, and I'm going to put it on the inside of the geom point argument. So I'm going to say alpha is equal to 0.5 and run that. And you can see now it's going to disappear from over here, and we're going to have just our points are going to be transparent. So again, alpha is the transparent argument. How transparent do I want these dots to be? And you can see that there's a lot of overlap that we maybe couldn't see before that now, because they're a little bit transparent, I can see, oh, there's like a green guy who's hiding back there that maybe we wouldn't have seen before. Any questions on alpha? Okay. Okay, so we have this pretty graph here, but the names are kind of funky. we have this fav num here, which is not great for a graph. You want the labels to be not just something that you can understand, but something that anybody can understand. So we're going to add on to what we just did. We're going to add xlab. So xlab, what xlab does is it says, I want this label to be for the x-axis. So xlab, x-axis label. And again, we need to use quotes. As we talked about earlier, we need quotes because we are saying, I want this character string. I'm not calling on an object that has my labels in it. I just, here's what my label is. So favorite number is on our x-axis. And we can do ylab. So ylab is what is the axis label for the y-axis. And this is number of, here, let me make it on the next line. Number of years at current institution. So now that we have our x and y labels, we still need labels for these things over here. These don't have their own fancy x, y, x lab, y lab arguments, but there's one that's just called labs that goes for anything. We can say anything that we want in there, so we have to tell it specifically just that coincides with our AES argument. So you can see here we put color equals favorite color. So in this labs argument, we're going to say color equals, and then what we want that to be. So color equals, and then let me make this on the next line. So color equals favorite color, and then we're going to use a comma. So comma because we have to tell it two things. We have to tell it the label for our color argument and the label for our size argument. So then I would say size is equal to our experience. And now if I run that, I get all of these different, the labels to show up on my graph. So we had xlab, ylab for the x and y axis. And then inside of this labs argument, we told it what we wanted the label to be for the color and the size. Okay, any questions on that? Yes, you could say x equals or y equals. But a lot of the times people are just using like x and y axes, so they like to do like, here's my x lab, here's my y lab. Okay, yes?
Is the size thing based on like the distribution? Or?
Yeah, so size is, it'll fit it to what your distribution is. So if I only had, because R doesn't know that like what is a meaningful like change. So if I only had like a 1 and a 2, it would give me like the small dot is a 1 and the big dot is a 2. So it's just going to give you like the size of your dot fit to your distribution, whether or not like you actually like 2 is considered like really bigger than 1. So it'll just fit it to whatever your distribution is. Did that answer your question? Yes, there is a way to change that, and you can actually set it to be to a specific, like, let's say you don't have, like, let's say our scale goes from 1 to 10, but in my data I only see 1 to 5. You can actually set it to be like what your, what the top should be, so it'll do it that way. And that you would actually do inside of, before you get to the graphing portion, which I can show you how to do that if you have specific questions on that. Okay. So any questions on the labeling part? Okay, so just like how we can add on to current pieces, we don't actually have to continually, copy what we had before. We can actually save it as an object and call upon that object. So we're going to take what we have what we just did, and I'm going to call it P. P for plot. I don't know, I'm not very inventive. So I'm now going to call all of this stuff is going to be called P. So if I were to run just P, we would get the same graph that we just had. But right now I want to show you guys how to do marginal plots. So marginal plots, you can't have a facet in a marginal plot, so we're going to actually just take that piece out right now. So see where we have facet grid. I'm just going to delete this whole piece and this plus because there's already a plus up on the next line. Okay, so delete facet grid because we can't have faceting when we do a marginal plot. So before we get too much further into that, I want you guys to install what we need to do the marginal plots. So install .packages gg extra. And then library gg extra. Okay, so again, we got rid of the faceting piece for the plot that we just did. And I'm actually going to add one other argument onto the end of this P plot, because when we do a marginal plot, so what a marginal plot is, let me start with that, is it's going to have something that's on the sides of our graph. It's going to have a plot that's along the axes of our plots. So I want to get rid of the legend where we have, over here we have this favorite number and experience. Over here, I'm going to get rid of this for a minute so that it's not in the way and doesn't look funky. I can show you guys also how you can flip it to the other side. But for now, I'm just going to get rid of it by saying theme. And then let me do this so you guys can see. Theme and then legend dot position. And then so this is where I could say legend dot position and then equals left, so I could just move it to the other side, but I'm actually just going to say none. I want to completely get rid of it for now because we don't want to have it. Okay, so I can run that, and now I have a base plot with all the information that I want, and then now it's called P. So I can call upon that object. If I were to just run P right now, I would get this exact plot, what I just typed out here. But we're going to add a marginal plot onto it. So it's gg marginal is the function. So gg marginal, and then P for what plot do we want to add these marginal plots onto. So P, and then type is equal to, let's start with a histogram. And if I run that, I get a marginal plot with a histogram on it. So you can see that I have histograms along the margins of my plot. So again, here I have gg marginal, and then P, which is the name of this data that we labeled P, and then type is equal to histogram. Any questions on that? Okay, so we can do the same thing. Instead of having a histogram, I want it to be a box plot. I just change type equals to box plot, and then when I run that, now I have this marginal box plots here. So I have a box plot here for coinciding with our x-axis here, coincides with this, and our y-axis, how distributed the data is in number of years on over here. Okay, questions on marginal plots? Was everybody able to get at least one of those to run?
Is there a built-in one for normal curve? Or?
I think it's called density. Yeah, so it's type equals density, I believe. Okay, any other questions on anything that we've covered so far? Yep.
If you wanted to do like a reaction time next to accuracy, is that GG marginal?
No. So what marginal does is marginal specifically is giving you a marginal plot of information that's in this graph. So what you're describing is more like faceting, where you want two graphs that are next to each other. That would be facets, not marginal plots, because marginal plots is only going to give you can only call on information that's already in that plot.
Anything you can scatter plot, you can marginal plot, right?
Yes, I would think that that's true, yeah. Okay, any questions on that stuff so far? Okay, so let's make a pie chart. Why are we booing? No hecklers.
No, you're doing fine.
Okay,
Pie
so
charts have fallen out of favor.
I see. Yeah. Right, but we're going to learn how to make one in case you want a pie chart. Okay, so first what we want to do, so I want to make a pie graph of software. So first what we want to do is we want to just look at what the distribution is. So $software inside of table. So the table function gives you the frequency of each of the answers. So you can see here we have this space for 2. That's just because I didn't replace the missing value, so it's just empty. So we have 2 people that did not answer this question. And then you can see we have 4 people who use Excel, 2 people who use GraphPad. So this is just giving us the distribution, but now we need to actually save this data so that we can call upon it in our graph. So we're going to call it soft, just for software. Again, I don't have a lot of creativity, so we're going to say data.frame. So data.frame is telling it I want to make a data frame, and I want to make a data frame that is exactly what we just looked at. So table of $software. So now if I call upon soft, I have this data frame that has a column called var1 and freak. So I want to replace these names so that when it shows up in my pie graph, it actually is meaningful to me. So I'm going to say col names of soft is equal to C and then software, comma, frequency. So that way when it shows up in my pie graph, I actually recognize what it actually means. And it won't just say var1. Okay, so now we're going to use ggplot again. ggplot, and now our data, instead of being D, it's soft because we just made this new data frame called soft. And then AES is equal to, so X is going to actually be equal to nothing. So the reason why that is because a pie graph actually starts off as a stacked bar plot, and we don't want anything on the x-axis because we want a single bar. We don't want multiple bars that have a certain variable associated. We want one bar, so we're just going to say we want nothing to split it up on the x-axis. And then y is equal to frequency. So, and then we want the fill equal to software. So what this is saying now is that, well, I guess it's not telling it a bar yet. We still have to tell it that, but if it already knew it was a bar, it's saying that I want nothing to split it on the x-axis. I want the bars to be associated with the frequency, and the group of the bars that fill, so the color of the bars, to be software. Okay, so we have to tell it that we want it to be a bar graph. So to do that, if you guys remember before when we did the bar plot, we actually used stat summary, but here we're going to use geom_bar because we already have the means or the information that we want to graph inside of this data set. So before we didn't have the means, we wanted to graph means, we wanted it to calculate the mean and then graph it. Here we already have it, so we're just going to say geom bar and then stat is equal to identity. So what this means, identity, so what this means is I want it to just graph exactly the number that it has in the data set. I don't want you to do anything with it. I just want stat equal to identity, graph what's there. Okay, so we also need to say width equals 1. So the reason why we need to do that is because if we were to leave that off, what the bar graph, it's in a little bit in the, let me show you. So if we didn't have it be equal to 1, you would get a little bit of edge here on the sides. And then what would end up happening is when we turn it into polar coordinates, you would get a hole in the center of your circle. So that's why we have to say width is equal to 1 so that we don't get a hole in the center of our pie graph. So if we were to run this now, we would see this. So we just have this stacked bar plot, but it's not a pie chart yet. So we have to tell it to make it into a circle. So what we're going to do is add on to what we already have, and we're going to add on and tell it to make polar coordinates. So right now it's in Cartesian coordinates, but we need it to be in polar coordinates. So we're going to say coord polar, and we have to tell it what variable we want it to turn into polar coordinates. So in this case, we want our y-axis. So we want it to go around in a circle based on this. Because if we were to do a circle here, it wouldn't do anything because we only have one x there. Yeah, Lindsay. Okay, have you gotten ggplot to run at all so far? No. Okay, can you type version into your console and then hit enter? And tell me what year it says? Okay, that should be okay. Sometimes if you have an old version of R, it's not compatible. Let me take a look real quick. Try downloading the newest version of, try RStudio first and see if that fixes it. Update RStudio, and then if that doesn't work, update R. Go through the website. So close that R session so that way when you open it, it'll open a new one. Okay, so if we were to just run this, what we would see is we have these weird stuff on the outside because it's telling us what the polar coordinates are, but we actually don't care about what the polar coordinates are. We don't care that it starts at 0. So what we want to do is make our theme be void. So you just do theme underscore void. And then when you run that, it's going to get rid of those, all that extra junk. So it's going to get rid of this telling us that it's frequency in x, and it's going to get rid of this polar coordinates, and it's just going to leave us with this circle. So now we have this pie chart, but I don't necessarily know how many people are in this SPSS group, so I know, okay, it looks about 50%, but I want to know exactly how many people are in that group. I can add it to the graph, so we're going to keep everything that we just had, and we're going to add on to it. So we're going to add geom text. So what geom text does is it allows us to put text anywhere on our graph that we want. And in this case, we want our labels to be associated with frequency. So label equals frequency. So what this is going to do is it's going to make the label, so the text that appears on our graph is going to be equal to what's in the frequency column of that soft data frame. Okay, so we also need to tell it where we want this text to appear. So we say position is position is equal to, and so if you remember before we had position dodge. In this case, we're going to use position stack. So the reason why we're using stack here is because before we turned it into polar coordinates, if you remember, it was a stacked bar graph. So the reason why we have to use position stack here is to tell it that we want our data to be stacked, I guess, is how that would be interpreted. But we also have to tell it where on the stack we want it to be. So I want it to be just equals 0.5. So what this is saying is the vertical adjustment. So I want it to be vertically halfway in between 0 and everything. So if I run that, then we can see that now halfway between the middle of our circle and the outside of the circle is where our label. So that's where that VJust piece comes into play, is it has this, it's 50% between the middle and the outside. Okay, any questions on that? Yeah.
So what determines why label has to go into AES and the outside?
Position is inside of the AES also. But I don't know that it needs to be. Try to see if you don't even need the AES. Sometimes you can have it in an AES and not in an AES, and it'll both run. But that's a great question. I don't actually know.
I did get an error.
Okay, so my guess here is because label is going to be a part of the aesthetics, we're telling it that, almost like when we were telling it what we want to be on the x-axis, we're telling it what we want the labels to be. So when we were saying like we want the colors to be equal to your favorite color, we're telling it we want labels to be equal to the frequency. So we're telling it something that it has to do with our variables and like how those are going to be put onto our graph.
So in your case, it looks like position is not in the AES.
Right. Yes, that's true.
And it doesn't work. So position has to be outside of it.
Right, because position doesn't, it's not a universal thing for the whole graph. So position is exclusive to the geom text argument, whereas if we were to put it on the inside here, it would say, okay, position is equal to this, but position of what? It doesn't know what we're talking about. So that's why it has to go inside of this geom text piece. Okay. Okay, any other questions on the pie graph before we continue and do a couple of last things? Yeah.
If you wanted to have, you can have like proportion instead of frequency.
Yeah, you can have whatever you want. You can have percentage, and you just have to make that data available in that in your data frame, and then you can call that instead of calling frequency. Okay. All right, so we're running low on time, so I want to show you a couple more things. So let's do the map really quick. So we have to install a package, so I'm going to skip that, and I'm just going to show you guys. I just want you to follow along and just take a look at what I'm showing you. I'm going to send out this our markdown file so that you guys have the code along with the results. But so zip code, this library zip code, gives us all of the latitude and longitude that's associated with a specific zip code. But it only does that for US. So sorry if you're not in the US, it's not going to show up on this graph. So the ggplot has a map data. So if we were to just run the map data piece, we would get this blank US map with all the states. But so you can see here, I have created a new data set where I merged the data that we have, our data set D, with the zip code data, which will tell us the latitude and longitude associated with each of the zip codes in our original data set. So if I then, on top of this, I add this geom point argument, and I also changed the alpha to be 0.5 because there's quite a bit of overlap. So if we didn't have the alpha to be 0.5, this would all just look like one dot here, but you can see that there are several that are on the same graph. So this is how you would add the points to the map graph. And if you guys have questions on any of this, like I said, I'm going to send out this code. But if you have questions on how to run it, please just feel free to email me. OK, so for a correlogram, like I showed you at the beginning, if we just run ggcorplot of the correlations, we're going to get this heat map. But this isn't super useful because it's difficult to actually see what's going on here because you're only changing by the color. So I added labels, so lab equals true. I'm adding labels, what is the correlation, and I also am changing the method to be equal to circle. So the circle method changes the size of the circle corresponding with the strength of the correlation. So a bigger circle is going to have a larger correlation. A smaller circle is a smaller, whether or not it's positive or negative. And the color is associated with whether it's positive or negative. And then I changed the color. So color is equal to red, white, and green. So that what that's doing is at -1, it's going to be red. At 0, it's going to be white. And at +1, it's going to be green. So the gradient will correspond with the correlation as well. OK, so this function is just getting the p-value out of our correlations. And I'm not going to walk through how to do this. I don't expect you guys to learn how to write functions today. But so let's just say, for sake of time, that we have this matrix that has all of the p-values associated with our correlations. I can add an insignificant argument, which says if it's not significant, then I want to add PCH. PCH stands for plotting character. So I want to add a plotting character on top of these points where they're not significant. So anything that's not significant is now going to have an X through it based on p.mat is telling what's the correlation matrix, which we said up here for the p-values. And then this pch.cex equals 10, that is the size of the X, so how big the X is. You can change that way. OK, so I have one more thing that I want to show you guys really quickly. Somebody asked me about how to do error bars. So there's a function in ggplot that's geom error bar. And then there's also geom error bar h if your bars go the opposite way. So if you did chord flip and your bars are going horizontally, you would use error bar h. So what this does is it adds the error bar based on your y min and max. So, or if you did h, it would be x min, x max, just because it's flipped. So here I graphed experience based on whether you came to my last workshop or not. And I did error bars around it. So this table here, if I use this function summary SE, it'll give me the standard deviation, standard error, and confidence interval. So here I use standard error. So I said experience minus the standard error is going to be my lower, and my upper is going to be experience plus the standard error. And then width equals 2. That's telling it how wide I want these error bars to be. So I wanted it to be 0.2 so that it's not, if you leave this off, it'll be the whole width of your bars. So I wanted it to be smaller, so I wrote that. Okay, any questions on anything that I just threw at you in the last hour and a half? No? Okay, so if you have specific graphing needs or any specific R needs at all, feel free to email me, and I can help you with because I obviously didn't cover every possible graph in all of R. That is like an infinite combination. So if you have specific things that you want to do for your own data, feel free to send me an email. Okay, you're free to go.